So in example 4, we want to use the information in the previous example to find how fast the camera angle of elevation is rising when the rocket is 12,000 feet high. So now it's the same problem as above, but now we're looking for how fast the angle is rising. So we're looking for d theta dt when the rocket is 12,000 feet high, which is the same thing that was happening up here. So how can I create a relationship, an equation that connects theta with this changing y? Well, this is my opposite side, and this is my adjacent side, so I can use tangent. Tangent of theta equals opposite over adjacent. And remember, this adjacent is a constant that never changes. So in order to make this look a little better, I'm going to multiply the 5,000 this way. 5,000 tangent theta equals y. Just doesn't really make much of a difference. You don't have to do that. So now let's differentiate with respect to time. I have 5,000 multiplied by secant squared theta multiplied by d theta dt equals the derivative of y with respect to time. So ultimately, we are trying to figure out what is d theta dt. So I'm going to plug in what I know and solve. So I have 5,000 multiplied by whatever secant theta is squared. I'll talk about that in a second. Multiplied by d theta dt equals dy dt, which in the previous example was 1,500. Well, what is secant of theta? Well, secant of theta, let's see, secant of theta is hypotenuse over adjacent. So in our previous problem, we already found that when this is 12,000, my hypotenuse is 13,000. So hypotenuse over adjacent would be 13,000 over 5,000. And those cancel. So my secant is 13 over 5 squared. So now how do I solve for d theta dt? I can divide that 5,000 this way. So I have 169 over 25 d theta dt equals 1,500 over 5,000. And I see my zeros are going to cancel here. 15 over 50, which also reduces to be 3/10. So now I have d theta dt equals 3 over 10 multiplied by the reciprocal, 25 over 169. I'm just going to leave my answer here. I don't feel like simplifying this, but my units would be in radians per second. Because remember, when we take the derivative, it is in radians. So I could simplify this some more, but I'm just going to save some time here, so we'll leave this an exact answer. This is okay for a free response, but if you had a calculator-based problem, you would have to give this as an answer. All right, let's try some more.